The 1930s saw considerable technological growth concerning military aircraft. Losing inventory space with the classic fabric overwood biplanes debuted during, and after, World War I, 1914 to 1918, with these being actively succeeded by more metal-skinned types relying on stronger metal understructures. While biplanes still existed in various frontline fighting forms, the monoplane was picking up steam as the aircraft wing design of choice from newer entries. In 1933, U.S. military personnel at Wright Field undertook work to flesh out a new all-modern bomber, one that could carry a warload of at least 2,500 pounds out to distances of 5,000 miles while maintaining a speed of 200 miles per hour. The United States Army Air Corps, USAAC, developed Project A around these specifications, and this was presented in 1934 to large aircraft makers Boeing and Martin. The intent was to develop a bombing platform capable of reaching, and subsequently protecting, American interests in far-off places like Alaska, Hawaii, and Panama. The Glenn L. Martin Company was founded in 1912 and contributed to the American aircraft effort of World War I, its biggest success being the MB-1 biplane bomber of 1918. From there came the MB-2 of the 1920s and culminated with the B-10 of 1932. The B-10's entry was of particular note as it marked the first mass-produced bomber that could outrun pursuit fighters of the period. Nearly 350 of this Martin product were produced. Martin's submission to the project was known internally as Model 145. To contend with the requested range and performance, a four-engined layout was selected, power stemming from 4X Allison V1710 liquid-cooled inline piston engines of 1,000 horsepower each. This proved something of a departure for the USAAC as its contemporary stock of large aircraft relied heavily on trusty air-cooled radial piston engines. Liquid-cooled inline engines aided high-altitude performance and could be fitted within more streamlined nacelles, therefore inherently improving aerodynamic efficiency. The trade-off in selecting an inline engine, however, was in the increased vulnerability to enemy fire due to the internally fragile nature of such an engine. For the USAAC program, the Model 145 was designated the XB-16 and a prototype was commissioned. Boeing's entry became the XB-15. A twin boom form was achieved in which the crew sections, bomb load, and other primary mission components were held in a centralized nacelle. The wide-spanning wing elements, showcasing a combined 140-foot span, were affixed to this structure and high-mounted. Each wing was to hold a pair of engine nacelles that were well contoured into the general shape of the wing elements themselves. The cockpit was stepped, the pilots overlooking the aircraft's nose section, and window panes accompanied the bombardier's position at the nose. The tail booms emanated from the wing trailing edges and were capped at their absolute ends by vertical tail fins. The booms were joined to one another by a shared horizontal plane that also protruded from the vertical fin sides outboard. A tricycle undercarriage, wholly retractable, was envisioned for the final design, and the standard operating crew would number 10. Initially, the XB-16 design was roughly equivalent in dimension to the Boeing submission, but it was decided by Martin to increase its bomber's size to meet the intended bomb load and range requirements. An increase to internal space allowed for greater fuel loads to be carried, and lifting and strength properties could be spread out over the larger aircraft as a result. The wingspan now measured 173 feet, even greater than the World War II-era Boeing B-29 Superfortress still to come, and these changes called for a new company model designator to be used, the Model 145B. The larger aircraft required more power, so an additional pair of engines was added. As the original set faced forward at each wing leading edge, the two additional engines were positioned to face aft at each wing trailing edge. In all, each wing would hold 3 engines apiece, with the new engine installs added directly behind the existing outboard fits. In the end, It was decided by USAAC authorities that the Martin bomber could not meet the intended requirements, particularly in the category of speed. It was estimated that the XB-16 was to have a maximum speed of 237 miles per hour, reach out to 5,000 miles, 3,200-mile mission range, and reach an altitude of 22,500 feet. Its rated bomb load was 12,180 pounds of internally held drop ordnance. As such, the XB-16 was cancelled before any tangible work on a prototype was ever completed. Boeing's XB-15 held greater promise, and a single, flyable prototype was completed which evolved to become the developmental Y-1B-20. Boeing's large bomber work eventually produced two classics of the period, the B-17 Flying Fortress and the aforementioned B-29, both proving their mettle over Europe and the Pacific theaters during World War II.